All right, on to problem number 3. A ship leaves port at 1 p.m. and sails in the direction of north 34 degrees west at a rate of 24 miles per hour. Another ship leaves the same port at 1:30 and travels north 56 degrees east at 18 miles per hour. How far apart in miles are the ships at 3 p.m.? All right, so this is where we got to be careful and understand a little bit about the compass. Okay, so I'm going to draw a little compass here. So it doesn't have to be perfect, but know what's going on. We've got north, we've got, whoops, put east in the wrong place there. There's east, south, and west. So when it says, let's call this, the middle is port, okay? First ship leaves port at 1 p.m. and sails in the direction of north. So we know we're going north. And then we're going to push the ship 34 degrees to the west. So from north, this ship is actually this angle right here from north towards the west is 34 degrees. Now, I'm also going to add in the distance. So 1 p.m. to 3 p.m. is 2 hours. And the ship was traveling at 24 miles per hour. So 24 miles per hour times 2 hours, that ship traveled 48 miles. Okay. Now we have a second ship that leaves the same port and travels north 56 degrees to the east. So from north, I want to push this basically the path of the ship 56 degrees to the east. So that's going to be 56 degrees. And it's 18 miles per hour. Now, this ship left at 1:30 and it is now 3 p.m. So that would be a total time of an hour and a half. So 1.5 hours. So 18 times 1.5 hours is 27 miles. And ultimately, we are trying to find how far apart these two ships are. So there's my X. Now, I'm going to do just a quick redraw of the triangle. So here's X. I know this is 48. I know this is 27. Now, this whole angle right here, right, this angle that I'm looking for as the base here, is the combination of the 34 degree angle and the 56 degree angle. Okay, so go ahead and add those up. And we end up finding out that this is actually a 90 degree angle between them. So I'm going to go ahead and mark that as 90. Now, you could say, well, if that's a 90 degree angle, then we could do Pythagorean theorem to find X. Totally fine. X is your hypotenuse. You could also just completely forget that part of the problem and say, well, it's still a law of cosines problem, and let's do law of cosines. Let's do that. So here's the side that we're looking for, opposite the known angle. So we're going to start with the side. X squared is equal to, pick one of the other two. So 48 squared. Use the other one, plus 27 squared minus 2 times 48 times 27. Cosine of, whoops, not 99, but 90. Okay. So we know everything on the right side here. So all of this, so 48 squared plus 27 squared minus 2 times 48 times 27. Cosine of 90 goes into a calculator, and you get X squared is equal to 3033. I'm going to take the square root of both sides. So X is equal to, and remember, because this is a distance, we're ignoring the fact that normally when you put a square root in the problem, you'd have a plus or minus. But let's go ahead and round this off to 2 decimal places. 07, and this is miles for our units. So the two ships are a little bit over 55 miles apart after at 3 p.m. Okay, so if you understand the compass, and we're going to show some more examples of this to be careful with how to set this up. If you've got questions, please let me know about it, okay? Problem number 4 is, we know the three sides of a triangle. So let's go ahead and draw myself a little triangle here. So let's see, 3, 5, and 7. Find the exact value of the cosine of the smallest angle of the triangle. Now, something to know about triangles. The smallest side is opposite the smallest angle. The largest side is opposite the largest angle. That will happen in any triangle that you work with, okay? So if we want the smallest angle, we're looking for x to be right there. So here's the side I know, here's the angle I'm looking for. So 3 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cosine of x. So I want to solve this because ultimately I want to know what cosine of x is equal to. All right, and in this case, I actually don't even want to know what the angle is equal to. It says find the exact value of the cosine of the smallest angle. So I want to know what a cosine is equal to. So let's do a little subtraction here. I'm going to subtract 5 squared. Actually, let me just put that on the other side already. So minus 5 squared and minus 7 squared. We'll get rid of both of those terms. So 3 squared minus 5 squared minus 7 squared is negative 65. At the same time I do that, I'm going to go ahead and multiply this out. So negative 2 times 5 times 7 is negative 70 cosine of x. So to solve for the cosine of x, I'm going to divide both sides by negative 70. So far, everything has been normal. Now, because it says I want to know the exact value, I'm going to take negative 65 divided by negative 70. It gets me a decimal answer, but I actually want the fractional answer that my calculator can create. So the cosine of x is equal to 13 over 14. All right, so problem number 4 can come in a lot of different formats. I can ask you for the cosine, I can ask you for x, I can ask for a lot of different things. So be careful that you make sure you answer exactly what's being asked for. I'm going to close this video out. I'll pop up a separate video with 5 and 6 and keep going through the rest of the worksheet.